Welcome to Week 5, Lesson B. This lesson, match a sequence with a table using rate of change, Part 2. And our goal is to use common ratio or common difference to describe rate of change. And we are going to identify independent and dependent variables. We are going to have a warm-up. Today I'm going to show you a graph, and I'd like you to find what is the same and different between the two graphs. We are going to continue our exploration. We are going to look at graphs and tables, and you're going to be marking a document using Kami again, and then a final reflection question. Here is your warm-up. We have graph A and graph B. What is similar between the two graphs? What is the difference between the two graphs? Has a rate of change of +2. How can you tell? If you take a look at the scale on the bottom of the screen, you will see that it's going up by 1. And on the y-axis, you can see the scale is also going up by 1. So every time you go from 1 to 2 terms, so you go over a term, you go up 2 values. This is 2 blocks high, and you have to read it against the scale to make sure you're reading 2 blocks high. The height from dot to dot is 2. So right here, the height is 2 blocks. And again, over here, the height is 2 blocks. On graph B, the scale is also counting up by 1s. I put in the extra numbers to make sure I was counting correctly on the x and y axis. But you can see that every time you go from one term to the next, so from one term to term 2, every time you're going over 1, it's increasing by 1 block. If you compare over here on the sides, it goes from 5 to 6. So increase of 1. Over here, increase of 2. So what was the same? You can find many things that are the same and different, but some of the main concepts to take away from this: same, they're both linear, and they're both consistent. Different, the rate of change is different. One is increasing by 2, one is increasing by 1. We are going to complete an activity similar to the one you completed in Lesson A. We are going to be marking on this document using Kami. You are going to continue the circles in the sequence by drawing the circles. In Table D, I want you to record the number of circles you drew in Term 5. And then on Graph D, I want you to continue the line. Can you explain your reasoning? And can you describe the overall rate of change? Sequence E. Complete sequence E by drawing the number of circles you would continue for Term 5. Table E. Record the number of circles you drew, and then continue Graph E by extending the line to represent the number of circles for Term 5. Can you explain your reasoning? Describe the overall rate of change. If you notice, this is an up-down pattern. Each time, the spaces between the circles in the sequence is 2. However, when it goes from 2 to 4, it's +2 increase. Going from term 2 to term 3, 4 to 6 circles is +2 increase. On this side of the pattern, it is declining. It goes from 6 to 4 circles, from term 3 to 4, minus 2. And when we go from 4 circles to 2 circles, it's another minus 2. So even though the space in between the numbers in the sequence is the same, it is not consistent because on this side it is positive 2, on this side it is negative 2. So we can draw 2 circles in here by continuing this symmetrical pattern. We can also record 2 circles on the table at term 5. And down here, when we extend the graph, it is 2 circles at term 5. So make sure you are noticing your scale. Between 4 and 6 is term 5. And then when we go up to 2, we can record our dot here and connect our line. The pattern increased and decreased by 2. It was inconsistent. So make sure you are correcting your worksheet to say these things. Also, notice the pattern. When it is perfectly, when the jumps are consistent, like the spaces between the numbers in the sequence are all the same number, it makes this pointy graph. And this is a new graph for us today. It's not quadratic. It's called absolute value. Okay. It also makes a V shape. All right. There's kind of the V shape in the word absolute value. So that's how I remember to call it absolute value when it is a pointy V shape. And what's causing this point? This is increasing by plus 2 on the graph right here from 4 to 6. From dot to dot, the graph increases by 2, and it does so on the other side too. Only one side goes up and one side goes down. So you get that perfect point right there. Sequence E. Sequence E, we are increasing the number of circles each time. It goes from 2 to 5 circles, 10, 17, and if you continue the pattern, you would draw 26 circles right here. Here are the increases. From 2 to 5 plus 3, from 5 to 10 plus 5, from 5 to 17 plus 7, and from 17 to 26 plus 9. So you can continue the pattern. 17 plus 9 is 26. When you plot term 5, you're going to go over to a 5. They left us a 5 on the graph so we could space it out this time. And you're going to go up just above 25 on the y-axis and record 26 circles and connect your graph. You can see the inconsistent jumps are making a curve. So this pattern is increasing. It is inconsistent. And when that happens, it's exponential. Make sure you label on the x-axis your independent variable for me. And on your y-axis, please label dependent variable. These are the independent and the dependent variables in the experiment. Our exit ticket. You are going to look at the graph and then answer the question. Please study the scale. The x values are 1, 2, 3, 4. The y values increase by 5s, 5, 10, 15. Notice where the dots are plotted along the graph. The question, Phaedrus claims that this graph shows a straight line. Is he correct? Yes or no? Explain why or why not. In this question, you were asked, is the graph a straight line? Well, the answer is no, and here's why. This is a curved line because it has inconsistent jumps or differences between the numbers. If you take a look at the dots plotted on the graph, at the bottom on the x-axis, you have term 1, term 2, term 3, term 4. And on the y-axis here, your scale, the dark solid lines is by 5s, but each grid line does count as 1. So if you take a look at the difference between the two dots plotted between term 1 and 2, it actually increases by 4 from term 2 to 3. The graph increases by 6. 1, 2, 3, 4, 5, 6, and you measure this against the y-axis. And then from term 3 to term 4, the dots increase by 8. Again, you count up 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that means that there's no common difference between the numbers. So the number is not all the same.